Hey guys, welcome back to NextWave News. Today we're unpacking a cosmic heavy hitter, the most massive black hole merger ever detected, and why it's rewriting our understanding of the universe. On November 23, 2023, gravitational wave observatories here on Earth detected a powerful ripple in space-time. The signal came from two colossal black holes, each over 100 times the mass of our Sun, colliding about 10 billion light-years away. When they merged, they created a single, monster black hole weighing in at somewhere between 225 and 265 solar masses, obliterating the previous record of around 140 m. This isn't just big, it's staggering. These aren't your typical stellar collapse black holes. Current astrophysical models suggest stars can't directly form black holes in this mass range. There's something called the mass gap, between about 60 and 130 m. Yet here they are, black holes of roughly 100 and 140 m earlier, and now this newly formed Leviathan defying those models. What's even more perplexing is their spin. These behemoths were rotating at nearly the theoretical maximum, one spinning at about 90% and the other around 80% of the cosmic speed limit. That level of spin hints that these black holes might be second generation, products of earlier mergers. Essentially, smaller black holes combined, spun up, combined again and repeated, ending up as these ultra-massive, fast-spinning giants. And that complicates everything. Are we catching black holes at the end of a cosmic lineage, formed within dense star clusters or near supermassive black holes? Or are we seeing something even more exotic, like black hole collisions fueled by swirling gas disks in galactic nuclei? Each theory has implications for how the universe builds its most extreme objects. This merger was brief, but telling. The gravitational wave signal lasted only about 0.1 seconds, capturing just the final ring-down phase where the new black hole settled. Yet even in that tiny moment, physicists were able to extract details about mass, spin, and origin. The event was announced at this week's major gravitational wave conference in Glasgow. But there's more. Detecting a black hole this massive opens a new frontier in gravitational wave astronomy. It's proof that there's a population of intermediate mass black holes, objects we've long suspected but rarely observed. And as detectors like LIGO, Virgo and Kagra grow more sensitive or expand to space-based missions like LISA, we're likely to discover even more of these cosmic titans. This is the dawn of a new era. Observing black hole mergers wasn't even possible before 2015. And now we're watching the most extreme events the universe can muster. Each detection pushes the boundaries of our understanding about star formation, galaxy evolution, and the very nature of gravity itself. Curious where this leads next? Drop a comment if you'd like to explore how second-generation black holes form, or what LISA will bring to the table. And if you're excited about these cosmic breakthroughs, be sure to subscribe and hit that bell so you never miss a NextWave News update. Catch you in the next one.